Solving linear systems of equations, we're going to solve these equations through the graphical method. So, first thing we're actually going to take a look at is what a linear equation, a system of equations is. And it's when we have two equations and two variables. Here, notice that we have not only just one equation, but when we have the one equation, x plus y being equal to 6, we can't solve that unless we're solving for one of the variables. And it's going to give us an expression on the other end that's not going to give us a finite answer. Now, when we can come up with an actual integer answer or integer answers when we have two equations and two variables. What we're going to check here is that whether or not this 5, 1 is going to be a solution to this system. In other words, this coordinate right here needs to work in both the x and y, right? When we substitute and then evaluate for both of these equations. If it does, then this is a solution. So let's try it out. We have x plus y being equal to 6. Or in other words, we have 5 plus 1 being equal to 6. And when we simplify completely, we have 6 is equal to 6. So that one checks out. The second one we have is 2 times x, which we're going to substitute as 5. Remember, when we substitute, and we're going to do that in parentheses, minus the 1 equal to 9. Okay, 2 times 5 is 10, minus 1 is 9. Or in other words, we have 9 being equal to 9. So there we go. This, of course, yes, is a solution because both of those verify and are solutions in this equation. Next, we're going to check if y equals negative x plus 2 and y is equal to 3x minus 2. Okay, this guy's going to be negative 1, this guy's going to be negative 5. So we're going to check to see if both of these work. Okay, so if it doesn't work for one, it doesn't work for either, right? It's got to work for both for it to be a solution. So the first one, we're going to have negative 5, right, and for y is equal to negative 1 plus 2. And I think you guys already see this is going negative 5 is equal to negative 1, which is 1 plus 2, or negative 5, which is not equal to 3. So right off the bat, we already know this is not a solution. Just a real quick thing, I'm going to evaluate the other one just while I'm kind of talking here. And it's going to show that this other one on the right will wind up being a solution, right? We'll have negative 5 equal to negative 5. So this guy checks out, but because this one does not, this is not a solution. So if we had gone about this in the other way, and the first one had checked out, and we think we're good to go, we have to make sure that we check both equations, okay? If the first one does work. However, if it doesn't, then we actually can move right along. We actually didn't need to necessarily evaluate through this second equation here. So let's actually see what happens when we graph here. Y being equal to negative x plus 5, and y being equal to 2x minus 1. So let's actually graph both of these. We're going to solve by graphing. And the reason that we're doing that evaluation is because once we see what we think the answer is, we can't just leave it to chance and just guess and say, hey, it looks close enough, that's what our answer is. We're going to take a look, make a conjecture about what that point is. And what we need to really take away from this lesson is that the solution is a point, because each of these equations creates a line, and two lines intersect at exactly one point. So let's go ahead and graph. 1, 2, 3, 4, 5. The y-axis, down 1 over 1, right? And here we go. That's one of my equations. And then we have negative 1 up 2 over 1. Goodness, I'm not even really sure what this is. It's probably at about 2, and then it looks like it's up about 1, 2, 3. So this right here, this looks like it's the point. Either way, it's the solution. So let's guess about what that actually is. It looks like it's 2, 3, but we can't just go with, oh, looks like, right? So we have to make sure that we verify, and we're going to test it out. Okay, so here we go. First one, we're going to put in 3. So 3 for y is equal to negative 2 plus 5 And of course, that's going to be 3 is equal to 3. That one checks out. Let's try the other one. 3, and for y, we're going to have 2 times 3. Sorry, 2 times 2. Goodness, x is equal to 2 minus 1. Or in other words, 3 is equal to 4 minus 1, which of course we're going to see that 3 is equal to 3, and that one also checks out. So the answer here is yes. It's 2, 3. That is our solution. All right. That's all I got for you for today. So go ahead and give it a shot, and we'll see how you do. Good luck.